Good evening, everyone. My name is Syndey and this is my AP Calculus group. To my right, I have Shelby Reynolds, and to my left, I have Julianna Justice and Sarah Young. And tonight, in our project-based learning, or PBL assignment, we will be demonstrating and discussing how to turf certain areas of our football fields. For our project, we chose a scenario in which challenged us to find the total cost of turfing certain parts of the field. Pilot Oil is donating artificial turf for our field. However, the company will not do the part of the field that goes from the track to the end zone. Therefore, our job is to make a proposal on how much this would cost to ensure that all parts of the field are covered. So our plan for the math portion of this presentation is first to measure all the parts of the field that needed to be covered from the track to the end zone. We did this by using an application known as Google Earth to get the most accurate measurements. Secondly, we need to find the area of these configurations by using a technique known as the trapezoidal rule that Sarah will be explaining in just a second. And then our last step is to determine the price of the turf with installation included, and this is our main goal for this project.
We found the cost by using the measurements to turf the parts of the field that need to be covered. We found more precise measurements by using what is known as the trapezoidal rule. The trapezoidal rule is represented by the change in x multiplied by y sub 0 plus 2y sub 1 plus 2y sub 2 and so on, ending with plus y sub 8.
I think our thing froze. Yeah, it's not changing currently with our computer. Oh, there it is. I think I'm gonna.
This happens to Mr. Howard all the time. Don't worry about it.
There we go. Okay.
My whiteboard pen freezes up all the time.
Mine only does it in a parent meeting.
Thank you.
When using the trapezoidal rule, the first step is defining the change in x. The change in x is represented by 1/2 multiplied by b minus a over n, which then represents b minus a over 2n. This change in x represents the width of each interval of the trapezoids. For the first step, we determine the length of the end zone, and this will then help determine the length of each interval. The purple line represented in the picture is 200 feet. This means we can make 20 trapezoids with 10-foot intervals.
And down here, we did the equation of the change of x, which was b minus a. And the reason that we have 200 minus 0, the total length here is 200, so we took the ending interval, which was 200, the distance of it, and we subtracted it by the starting distance, which was 0. So we would get 200. We then divided it by 20, which is how many trapezoids we plan to use on the end zone, and we got 10-foot intervals from this.
20 trapezoids are made here using 10-foot intervals. Now we plug in the height of each trapezoid we found from Google Earth into the formula to find the total area. Here, the 5 represents the change in x, and the numbers multiplied by 2 represents the heights of each trapezoid. The total area of this end zone is 12,444.5 square feet.
Okay, for our next step, as you can see right here, there's a little blacktop space that we can't turf because it's part of the track. So our next step was to find the area of that blacktop space so we can subtract it from the total area of the end zone so we know how much we need to turf.
The source changer for the actual
So as you can see, the arrow is pointing toward the blacktop
just
space.
switch them over to hardware.
And what I did for this is I divided the blacktop area into halves so it would make it easier for me to solve the trapezoidal rule. So I took the length of that red line right there, and set up 8 trapezoids to, I set up 8 trapezoids to find the length of each of these red lines according to the trapezoidal rule. And it is essentially the same thing that we did before. So each interval was 5 feet. So we did 5. We did 5, and then we halved it because we had to account for the area of the trapezoid. And we plug in the length for each line, as you can see below. And then we did this for the left side and the right side, so it would make it easier. And at the end of that, I added both of the areas together to get 2,228 square feet. After doing this, I took the total area of the end zone, which was 12,445.5 feet squared, and I took the total area of the blacktop, which was 2,228 feet squared, and I subtracted these together to get the total amount of the end zone that we would be turfing, and I got 10,216.5 square feet.
Okay, so the third step is almost identical to the first step that Sarah explained, other than it's the end zone near the baseball field instead of facing the school. So our steps are going to be the exact same for this one, and the measurements are the exact same. So we stuck with our 200 feet for that bottom line across the end zone, and then we still used 20 trapezoids with 10-foot intervals. So to find the total area of this side, we're going to plug in the height of each trapezoid and multiply it by 2. The equation up there is just as Sarah explained earlier. It's the change of x equals b minus a over 2n from the trapezoidal rule. So we still have 5 for our change in x, and that is outside of the bracket there on the left. Everything inside the parentheses, as far as the decimals go, that is the height of the trapezoids that we found on Google Earth. We multiplied those by 2, just as the trapezoidal rule calls for, and that gave us a grand total of 12,378.65 square feet.
So for our fourth step, we had to take into account the discus and shot put regions and subtract them from the total area that we found in the end zones. So to find the area of the shot put, we created a 90-degree angle and then did the trapezoid rule. And as explained before, this is just the math shown out, and those are the heights. And we came up with 2,342.27 square feet. And then for the discus region, we did the exact same thing, and we came up with 590.275 square feet. And then we added the shot put and discus areas together, and we got 2,933.02 square feet. And then we subtracted the total shot put and discus from the area of the end zone, and it gave us 9,445.63 square feet. And then for our fifth step, we added the total area that we got from the first end zone and the total area from the second end zone together to figure out the total area of turfing that we would have to do. We got 19,662.13 square feet.
Okay, so the final step was our goal for this project, finding out how much this is going to cost us. So we contacted a local turfing company known as Playwright, and they gave us an estimate of $8 per square foot with the installation cost included in that. So what we did is we took our total area that Julianna just mentioned, which was 19,662.13 square feet, and multiplied that by $8. And that gave us $157,297.04 for our total price and how much that's going to cost. And that is all.
Any questions?
Well, sure I do.
Where's the contribution bucket?
Yeah, we need to pass the plate, don't we?
Plus the paid place in the classroom, just spare change, pennies.
I have 3 quick questions. May require answers longer. I'm a biology chemistry guy, so I don't know if your math answers are correct. I'll leave that up to Mr. Howard, but I want to talk about the methods in which you got there. Back in April of 2013, we started this run for one-to-one technology, but we kind of talked about personalization at the same time, how we were going to change the way we taught students in class. And so you've been taught more traditional ways through all of your years of schooling, and then you've stumbled onto this. We're doing things a little bit different. So if one of you could just step out and tell me what you like best about learning this way and what you like least about learning this way, to help me better understand so that I can work with my teachers in the future.
Okay, one of the things I like least about this way is that human error, essentially, because when we try to measure the trapezoids, we get decimals, and they're not always accurate, per se. Because, like, I believe there were 2 other groups that did the same question, and we all got different areas around the same place, because we all had different ways of us measuring it, and each person did it measuring differently. Some people averaged it together. So I think just human error when it comes to that, because there's not an exact amount of area that we know of that we should turn. What I did like about it, though, is like it made it more accessible for us as a group to do it together, because when we were on Google Earth, we could compare each other and we could talk about it. It didn't take as much time as us actually going out there and measuring it by hand, which was a lot nicer than doing that. So I guess it's more convenient as students for us to have it. And then the least thing I liked about it was the human error that it presented us with.
Okay. So I want to go back to this holding each other accountable piece. You said you had access to one another. Anytime that we do a group project, there's always this worry that one person's going to do all the work. And so for positive interdependence, how did you all hold each other accountable for the work so that everybody did equal amount of work?
I would say that when we started this project, we kind of divvied it up between whose responsibility was what. So like you saw, different people talking for different steps. We just kind of put that responsibility on each other, and then we used Google Slides to work on our PowerPoint so that we could all be on that website together working on it at the same time. Nothing would be affected, and we could see when each other was working. So like if I got on there and I hadn't seen Syndey log on for 2 days, I would know that Syndey probably hasn't contributed to her part of the presentation in 2 days.
But Syndey did, though, didn't she?
Yes.
Yeah. I'm sure she did.
Mr. Berry, tomorrow they will be doing a peer review on the members of their group to how they all contribute. There's, I don't know,
Can we come for that?
You sure can. I don't even remember how many categories I had on that this morning. I showed it to them so they knew what they were getting ready. 8 or 10 or something that they'll have to go through and rate their team members.
Okay, good. Well, you answered my third question. I want to know how you communicated, and if it was difficult to get together and make time for each other, but if you're using Google anything, you're on the same page. So that answered my question.
Thank you.
Okay.
Anybody else? Question or comment?
Is there a way to figure a percentage of variation between the groups? I mean, can you figure in like a percentage of plus or minus your exact figure?
As far as like how close the measurements would be?
Right.
We could take the total area and the total cost that we got from all the groups, and we could average them together to get an average amount close to the range that we need.
Did you try to contact more than one person about the cost of the turf?
Yes, I did. I contacted 3 people.
Okay, and $8 was the cheapest.
It was I'd say the most accurate. I think one was 9. I know that the other 2 groups, I believe they went with the same company as well, the $8. So we kind of had conversations about that as well. So I chose to go with that.
But you got a better deal. The other groups got it at $8.50 and you got it at $8. So somebody must have been talking very well for your group. So Mr. Berry, be sure to get them to do your negotiating.
It's been interesting being here, listening to the groups. Some of the people hung up on them and would not talk to them when they found out it was a project. And then some of the companies, hey, it's a project. Yeah, but I'm going to come out there. Let me come out. I want the job. And you're going. You couldn't convince them. This is just a project. They're not. They don't have a
measure, didn't they?
Yeah, they were ready to go, man. One company, Mr. Berry, wants to do the whole field, and they never did convince him.
Wow.
We really aren't doing this, that sort of thing. So that has been fun listening to those conversations, so,
But it could be real, because Mr. Berry may want to finish that out.
yeah,
Yeah,
included in our plan.
we were talking about it. That's where I was before this.
Our PowerPoint as an example.
I would love for
It'd be
you to come and do
great.
that presentation. yes.
I would do it.
Well, girls, thank you all very much.
Great job.